I like kind of took for granted that you would know about the trig ratios. Like when I asked you after you found the third side length on that pink sheet to go ahead and find sine, cosine, and tangent. So groups had to kind of talk about that, and we all kind of remembered from geometry that SOHCAHTOA. So today I'm going to talk specifically about these trig ratios. So first of all, what does it mean when it asks you to do a trig function or find a trig ratio? It's talking about the ratio of lengths of just two of the sides of the right triangle. And when I say the word ratio in math, you know, when you first learned ratios, they probably looked like they had that colon, 2, colon, 3. Okay? But eventually we kind of evolve and we start rewriting ratios as fractions. So that's what you kind of want to think about in your head when you see the word ratio, or even the word rational, right? It has the word ratio in it, so it means a fraction. So when we're talking about like find sine, cosine, and tangent, if we don't know the angle measure and we're not using our calculator, we mean just write the fraction. And that goes back to that whole SOHCAHTOA piece. So I would draw a right triangle in your notes, label one of the acute angles theta. And then in regards to theta, you can name your two legs opposite and adjacent, right? Okay, the adjacent side is going to be the leg that forms the angle with the hypotenuse. So here's my adjacent side. The opposite side is the side opposite the angle, or I always think about it, it's the side that's not part of the angle. Okay, so there's my opposite. And then every right triangle has a hypotenuse. So we have the three basic trig ratios down here, sine, cosine, and tangent. And make sure you know SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, so those are what I would call my three basic trig ratios. They're the ones that everyone definitely learned in geometry. And even when you come in here in August, I would expect everybody to know SOHCAHTOA, be able to do those three trig ratios. Now, I asked fifth hour last week if they thought that they had ever heard of the other trig ratios. So first I'm going to name them, and I'm going to ask you the same question. Do these sound familiar? Cosecant, secant, and cotangent. Have you heard those before? Some people are saying yeah, and some people are saying like maybe not. Okay. So there are actually 6 trig ratios that we can create. The other 3 trig ratios are just the reciprocals of the trig ratios that we already have. So what does reciprocal mean? In math, what are we going to do? We're just going to flip these fractions. So we renamed, like, what if you don't have opposite over hypotenuse? What if you do hypotenuse over opposite? Or you do hypotenuse over adjacent, or adjacent over opposite? We renamed those. Okay, so I'm going to move this over. Move this up so you can see better. And I would copy down their abbreviations. I'll write out how you say them, like their full names, right, as well. Okay, they are cosecant, which is abbreviated CSC, secant, which is abbreviated SEC, and cotangent, COT, not cot, just like sine is not sin. And I have them lined up right next to their reciprocal trig function. So cosecant is the reciprocal to sine. Okay. So we're going to flip that opposite over hypotenuse. It's going to be hypotenuse over opposite. Secant is the reciprocal to cosine. So that's going to be hypotenuse over adjacent. Now, stop and look at those two just really quickly. It's easy in the beginning, if you haven't seen these before, to think that cosine and cosecant will go together, right? Because they both have the co. But that's actually not true. I always just try to remember my trig ratios when I was first learning that, like, the S and the C's mismatch on reciprocals, right? So, like, a sine matches with a cosecant and a cosine matches with a secant. So they don't actually match by letters. And then tangent and cotangent, they're reciprocals, so that's going to be adjacent over opposite. So I'm going to say these are the three reciprocal trig ratios. I'm having a hard time spelling ratios today. And the thing that I would just try to remember about the reciprocal trig ratios is you don't need a new SOHCAHTOA for this. You just have to know, like, which one they match with and flip. Right? Now I will write down here down at the bottom, just in case anybody wants to, what they actually, how you actually say them or read them. Even though we have the abbreviations, we still like say the whole word. And I do that even for the three basic, right? I don't say tan theta, I say tangent theta. Okay, so you can write the abbreviation, but you should say the full name of it. Okay, so maybe that brought back to memory, like if some geometry classes had talked about the three reciprocal trig ratios, and at first you thought you hadn't learned them. Maybe you have, and then maybe still not every class talked about reciprocal ratios. Okay, but not too terribly hard, just flip what you know. Okay. Any questions so far? The rest of our notes is just a couple of examples. Okay, so you could have an example like this one, where I provide a picture of a triangle. And note that we're talking about, remember the heading here is right triangle trigonometry. So these ratios only work with right triangles. If we have an obtuse triangle or an acute triangle, we can't do sine, cosine, tangent. So here I give you a triangle. I'm asking you to evaluate the 6 trig functions. So you might see it interchangeably in directions. It might say trig function or trig ratios. So I want to do all 6. Okay, for this particular triangle, so I'm going to go ahead and write these out. I might have to move them over so I have more room. Okay, those are the 6 that I want. I'm going to slide this over so I'll be able to write my ratio. Okay, what do you think I should do first? Delaney? Hey, maybe like think about which sides you know. So here's theta. And in relation to theta, of course, 7 is our hypotenuse because that's opposite the right angle, right? And then the 4 is actually making the angle with the hypotenuse, so that side is part of the angle. This would be the adjacent side. Okay, and then up here we have the opposite side. But Delaney's saying, well, if I've got adjacent and hypotenuse, I know I can answer cosine, right? So cosine is 4 over 7 and secant is 7 over 4. Done. What do you suppose I might do next? Stefan? Yeah, every other trig ratio requires that I know the opposite side, right? I didn't give you the opposite side, but can you find the opposite side if you have two? Yeah, we did this on Friday. What would we use? A squared plus b squared equals c squared. That's your Pythagorean theorem. So the hypotenuse is always your c squared, so we would have something like 4 squared plus, it doesn't matter what variable you use, a, b, x, y, it doesn't really matter, equals 7 squared. That's 16 plus x squared equals 49. That's x squared equals, what, 33. So x is the square root of 33. Okay, so now I can do opposite over hypotenuse for my sine. That's going to be square root 33 over 7. Then I automatically know what my cosecant is, right? Just flip this one. 7 over square root 33. What do you think about that answer? No good to leave it alone, right? You're not allowed to leave radicals in the denominator. So we're going to have to rationalize. Since I'm low on room, I'm going to rationalize up here. 7 over square root 33. Whatever radical is in your denominator, just multiply the top and bottom by that well-chosen 1, square root 33 over square root 33. And then your answer on the top will be 7 square root 33. And on the bottom, remember, it doesn't just disappear. A square root 33 times square root 33 is 33. Okay, so squeeze that in. Okay, now this is really great because in this chapter, you'll get really, really good at rationalizing denominators. Okay. And so some people maybe won't always have to do all that work. They'll kind of be able to see just looking at it with a radical in the denominator what it will look like in the end. Okay, and that's fine. And then, of course, you can do tangent, right? Square root 33 over 4, and then that would be 4 over square root 33. We'll rationalize it by multiplying by square root 33 on the top and the bottom. So that's going to be 4 square root 33 over 33. So even if I only provide you 2 sides, you can still do all 6 trig ratios. You can find the missing side. All right, I'm going to let you and your pod talk about my second example. My second example is going to be a little bit different because I'm not going to start by giving you the picture. So in my second example, I tell you something about a right triangle. So in a right triangle, theta is an acute angle, so it's not the right angle, it's one of the other 2 angles. And the sine of theta is 3 over 7. Evaluate the other 5 trig functions or trig ratios of theta. So I'm going to let your groups brainstorm what you might do first. So have a conversation with your groups. If you know that the sine of theta is 3 over 7, what are you going to do? What would you do first? Tell your groups.
And the opposite of sine.
two things when I was walking around the room. I like both of them. Okay. So right away I heard some groups talking about, okay, if you have sine, think about SOHCAHTOA. You have opposite over hypotenuse. So the opposite side has a length of 3 and the hypotenuse has a length of 7. And then some groups said, well, of course, if you know sine, you automatically know cosecant. So we could just flip that 7 over 3. But in order to find the other 4 trig ratios, cosine, secant, tangent, cotangent, they all require that I know A. So I'm going to have to solve for the missing side. Now, the second thing I really liked as I went around the room was I saw different groups drawing right triangles. And here's the thing to remember, if I just am telling you about a right triangle, it doesn't matter what your right triangle looks like at all, right? However you draw it in whatever orientation or size is no big deal. Okay, of course, you've got to label your hypotenuse to be 7, and then, you know, you could really label either side to be 3, or you can put your angle down first. So do you want your angle to be up at this top angle, or like down at this bottom angle? Then what side is the opposite side is how I decide. Okay, so your angle is really important in that right triangle, but other than that, it does not matter how you draw it. Okay. So you probably went through the Pythagorean theorem to find that missing side length. So that would be something like 3 squared plus x squared equals 7 squared. This time it's 9 plus x squared equals 49. So x squared equals 40. And we're going to square root both sides. The square root of 40, you don't want to write as a decimal. Now, we did that on our pink sheet last Friday. But what we want to do is we want to leave it in its exact form. So that's really like the square root of 4 times 10. And the square root of 4 is 2. So this missing side is 2 square root 10. And then I can use that for adjacent. So for cosine, I can say 2 square root 10 over 7. I can see if these numbers reduce 2 and 7, but they do not, so I'm good. Tangent is opposite over adjacent, so that's going to be 3 over 2 square root 10. I'm going to rationalize that one down here. Okay, there's different steps you can take to rationalize. You can multiply by the whole denominator, 2 square root 10, if you want. Just be aware that that means you're going to have a 2 on the top and the bottom that you could cancel. So it means you have more simplifying at the end. Usually what I do is I just multiply by that radical, right? I need to get rid of the square root of 10, so I'm going to multiply by a square root of 10. So then in my numerator, I'll have 3 square root 10. In my denominator, remember, square root 10 times square root 10 doesn't disappear. It turns into a 10, and that's going to be 20. So this is going to be 3 square root 10 over 20. Okay. And again, I could check 3 over 20, but that doesn't simplify. This one is going to be, 7 over 2 square root 10 using the same method. That's going to be 7 square root 10 over 20. And then the cotangent here, rather than flipping my rationalized answer, I'll flip my original one because then I won't have to rationalize. It's adjacent 2 square root 10 over 3. If you flipped your rationalized answer for tangent, okay, so if the tangent was 3 square root, sorry, there should be a theta there, 3 square root 10 over 20, and then you do cotangent with that one, you do 20 over 3 square root 10, you multiply by a square root of 10, you get 20 square root of 10 over 30, which is 2 square root 10 over 3. But it's just a lot faster to go back to adjacent over hypotenuse at that point. Okay, that's basically all we're doing today. Okay. Now, one thing to note, if you type these into your calculator like these ratios, these will not match the decimals on that pink sheet from Friday. So what that's saying is these ratio of sides are not the same of a 45, 45, 90 or 30, 60, 90 triangle. Like it's not 1, 1, square root 2, or it's not 1, square root 3, 2. So these angles, thetas, right now we don't know what they are, and we don't really care. We're just looking at the ratio of side lengths. So if you see a 30, 60, 90, or a 45, 45, 90, you're going to do like you did in the warm-up. You don't even need trig. You just know the ratio of side lengths. If you have an angle that you don't know, then one thing we would want is all the side lengths, okay, so that we can do the different trig ratios. Okay, so here is your homework assignment. We have about 20 minutes. That's a nice chunk of time. There's only, 9 problems? You can get quite a bit of this done. And then if you need any help with radicals, rationalizing, you can get that help from me or from your group members.